In this lesson, we're going to look at graphing linear, so line, relations. So from an equation, from a table of values, from a graph, all these different ways that we can come up with plotting the points on a grid. So you may not have seen plotting points on a grid before, so we're going to go through the first thing, plotting points on a grid using a table of values. So we've seen what a table of values is. It's like this a thing called sort of a T-chart sometimes, where the X values are on the left and the Y values are on the right. This is a grid I have. It goes from -10 to 10. This is along the X axis. And it goes from -10 to 10 along the Y axis. So this Cartesian plane has two axes, X and Y. If you go up further in math, they actually have a Z axis too, and you can graph three-dimensional graphs, which is quite fun. But in this course, we're just looking at X and Y. X is along the horizontal, Y is along the vertical. And we have all these values from negatives to positives, from negatives to positives. If you see it skips a value in between, it skips -9, -7, but those values are implied by the lines, and there's little ticks on the actual axis itself to show where those values would be. So the first value I have for X is -2. We plugged it into this equation, Y equals -3x plus 1. We plugged a -2 into X to get -3 times -2, which is 6. Positive 6, because you have a negative times a negative. Plus 1, so 6 plus 1 is 7. So that first value, the first point I have, is -2, 7. And the way we write that point in coordinates, one second here. The way I write it in coordinate form is -2, 7. So I separate the two values with a comma. I write the X term first, and then I write the Y term second. So X goes first, Y goes second. When I'm plotting the point on the graph, I go along my X axis first, and I don't plot the points. These aren't 2 points I'm going to plot. It's 1. So I go along the X axis. I go to 1, 2, back. So to -1, -2. And then I go up 7 on the Y axis. So back 1, 2, up 1, 2, 3, 4, 5, 6, 7. And I put my first point at -2, 7. That's where that point is. -2, 7. My next point, so I've taken my X value of -1, I plug it into the equation, so -3 times -1 is 3, a positive 3, plus 1 is a positive 4. Notice these are going down, 7 to 4 to 1 to -2 to -5. That's why my value is -3 in front of my X. And notice when X is 0, Y is 1, positive 1, that's why I have a plus 1 at the end. That's where they got the equation from. So for the next point though, -1, 4, I can write that as -1, 4. -1 is my X value, 4 is my Y value. So I go to -1 on my X axis, and then I go up 1, 2, 3, 4, and I put my next point, which is right there. It's going to overlap on the 4, so I'll make it a little messy. The next point I have is 0, 1. Again, you plug the 0 in, -3 times 0 plus 1 is 1. 0, 1, 0 is right at the very center of my Cartesian of the plane, right in the very center. It's called the origin. 0, 0 is the origin. This point goes nowhere along the x-axis. It stays right in the center, but it goes up 1 value on the y-axis, so I put my point right on my y-axis at the value of 1. The next point is 1, -2. Now I have some negative values, so what do I do with those? Well, first of all, I'm going to go over 1 on my x-axis, and I'm going to go down 2 on my y-axis, so I put my point right here. And my final value of 2, -5, or 2, sorry, x equals 2, y equals -5 is 2, -5. I'm writing these all as coordinate points with my x term first and my y term last, or second. So I go over 2 along my x-axis, and I go down 5 along my y-axis. So 1, 2, 3, 4, 5, and I put my point right there. You can probably notice right away that these dots actually form a straight line that goes all the way down. And I would put arrows on both ends if I was to graph this as a line. So, plotting points on a grid. I'm going to get rid of the line for now because all we did was plot the points on a grid. We weren't asked to connect them as a line, but if we were, if the question was graph the following line, then you would in fact connect the dots with a single line that goes through them, and I would put arrows on the ends to show that it's going to continue in that pattern forever. But just note how we got these values. Well, this time it was given to us, the values for x and the equation, and then the values for y. But how do we convert those to coordinate points and then convert those to write on our graph? Okay, so we have a table of values, which gave us the coordinate points, which give us the graph. Let's look at another example. So this is a word problem. So one of the largest cruise ships, it's called Allure of the Seas, uses fuel at a rate of 5,210 liters per hour, which gives us this equation right here, which is F for the amount of fuel, it says below, equals 5,210 times T, which is the amount of time in hours traveled. So we create a graph using this information. This is taken straight from your book. We have the amount of time going up from 0 all the way to 7. So we can see that at time 0, the amount of fuel used is 0, of course. But on the graph, that corresponds to that point way at the bottom, at 0, what we would say 0, 0. This point is, in fact, on the origin. Okay, so 0, 0, which is the point way down there. We have the next point at 1, 5,210, which is at 1, 5,210. And so on. 2 at 10,420, 2, 10,420 roughly. We're going to be estimating a little bit in this graph because the values are so large. And notice that the y-axis, or the f-axis in this case, goes up by 10,000s because the values are so big. But you always start at 0. You don't start at 10,000. Start at 0, 10,000, 20, 30, 40, 50, and so on. And then again, these values are just kind of estimated. So just to give you an idea of how large this ship is, I found some pictures of it. I found a picture of it docked. This isn't a very high resolution picture, but this is the picture, a picture of the cruise ship docked, and it is massive. So this is a huge building. This is the dock here. You can see that if a car, even a car was on this, it would look very tiny. As you can see them over here, these cars are very tiny. For another kind of picture to see how big this thing is. So down here at the bottom of this chart, we have a blue whale. The blue whale is the largest mammal on Earth. And it is 103 feet long. And if you can see up here, if you've ever been to England and seen Big Ben, that's how tall Big Ben is. This is how tall the Statue of Liberty is. And this ship, Allure of the Seas, is gigantic. It is huge. And the amount of fuel it uses, if you know how much fuel like your car or average van uses, this is by far more. To fill up my van, it's about a 70 or 80 liters, and then that lasts me about a week. This uses 5,210 liters every hour, and it's graphed here. So some questions you might be asked about this are, like the first one, approximately how much fuel is used in 8 hours. So if it continues on this pattern, and I'm drawing these dots, in 8 hours, that's the next one over along the bottom, 7, 8. And if I was to draw the dot, or plot the red dot, where would it go? It would go roughly, because this is a straight line, it would go a little bit, maybe about there or so. So we'd say, and what does that correspond to? About 40,000. So I'll do a little tilde, which means roughly or about, and that would be around 40,000 liters. Next question, how long can the ship travel if it uses approximately 60,000 liters of fuel? Well, let's continue putting dots here. So 8 would be roughly there, 9 would be maybe about there, 10 would be just about there, and 11 might be up at the top there. So you can kind of see this pattern develop, and you can see that for 60,000, which is way up here, that's the line we were looking for. it looks like it's roughly about 11 hours. So after 11 hours, this cruise ship has used 60,000 liters of fuel. And remember I said my van takes about maybe 70, 60 if it's like a 3/4 tank. So if I took 60,000 liters and I divided that by my van, which I think is about, I can't remember, let's say 75. That's about 800 tanks of my van. So my van, I can fill up 800 times to use up the same amount of fuel that this ship uses in 11 hours. And a full tank of gas in my van will probably last me about a week. So this is a lot of fuel. Cruise ships use an astronomical amount of fuel. Okay, now let's look at how to graph using a table of values. So if we're given a table of values, we have the equation. It's best to pick, now I don't know, mostly in the book they give you values for x, but it's best to pick some negatives. Definitely 0, right? Because you want to figure out, you know what that value at the end is. You definitely want 0 for an x value and some positives. So I usually say it's a really good idea, -3, -2, -1, 0, 1, 2, 3. Those values you just put in for x. You just plug those in, or you just put those, you write them right down. You don't have to come up with those, or you don't have to like solve anything for it. Those are just values that you're choosing on your own. The y values, what you get out, you have to plug each one of these into the equation, right? So -3 I plug into x for my y. So just like we did in the first lesson. So -3 times 2 is -6. If you want to write this down, you can. You have -6. So -6, and then you have +1. And -6 plus 1 is -5. So your coordinate point would be -3, -5. That would be your first coordinate. And we could plot that on our graph. We could say, okay, well, I'm going to go back. Remember, this is my x and this is my y. So I go back 1, 2, 3 to -3. And then I go down 1, 2, 3, 4, 5 to -5. And I put my first point. The next value, -2, plug it in. So -2 times 2 is -4. And -4 plus 1 is -3. So I get the point -2, -3. So I go over to -2, and then I go down 1, 2, 3, and I put my next point at -2, -3. -1 I plug in, so I get -2 times, 2 times -1, which is -2. And then I add 1 to that, so I get -2 plus 1, which is equal to, -2 plus 1 is -1. So I get a value, or a coordinate point of -1, -1. And if I go over my graph, -1, -1, I go over -1 on my x-axis, and then down 1 on my y, and then I put a point right there. You can see a pattern emerging for sure, right? Each one of these things, -5, -3, -1, these are all going up by 2, right? They're all going up by 2. So if you see that pattern, you can maybe start to fill in the rest of the chart. You don't need to plug in every single value as long as you start seeing the pattern. Do 3 first though, at least. Do 3. So I plug a 0 in. 2 times 0 is 0, of course, plus 1 is 1. So I get the next point of 0, 1. Let's just solve for all of these points first. I plug a 1 in. Well, you know that these are all going to go up by 2. So 1, the next one should be 3, plus 2 again, because these are all going to go up by 2, is going to be 5. And going up by 2 again should be 7. So I get all these points. I get 3, or 1, 3. I get 2, 5. And I get my final point of 3, 7. So I can plot all these points on my graph. Next one is 0, 1. So 0 on my x-axis, up 1 on my y-axis is my point there. 1, 3, I go over 1 on my x-axis, up 1, 2, 3, put a point. 2, 5, so I go over 2, and then go up 1, 2, 3, 4, 5. And my last point, 3, 7, I go over 1, 2, 3, and I go up 1, 2, 3, 4, 5, 6, 7, and put my point. So I created a graph. I can connect the dots with my line as long as it's straight. And you get a picture of a straight line that goes through all the points that you plotted, and you get the equation of that line, which was 2x plus 1. Notice we've chose values for x, -3 all the way to 3, -3 to 3, including 0, because you need that point 0. It's very important. And some negatives and some positives, plugging in values into the equation, and then looking at the pattern that starts to come up to get the other points in the table of values. There's a lot to cover in this lesson, I know, but it's very important that you understand how we're coming up with this stuff. The last one we're going to do is very similar to the first one, only we're going to have to come up with the equation too, just like we did in the first lesson. We're going to look at the equation as well. Plotting the points is easy because each one of these we know just turns into a coordinate point, -3, -10. This one is -2, -7. This one here is -1, -4. The next one is 0, -1. 1, 2, and 2, 5. So we put all of these values into coordinate points so that we can graph them. And we can plot all these points in the graph, -1, 2, 3, and -10, which is at the bottom. So -1, 2, 3, and then all the way down to the bottom. I don't need to count. The values are right there anyways. -2, -7, -2, and then -7, not quite to -8, all the way down there. Then we have 1, -4. So now we're going over, or no, -1. -1, -4. So I go over 1, down 4 to there. Then I have 0, -1. So 0 and then down 1 right there. Then I have 1, 2, which is up here, over 1, up 2, and then 2, 5, over 2, up, not to 6, that would be 6, 5 is 1 less, which is there. So I plotted all my points. I've drawn my straight line through all of them using a ruler. I can't use a ruler because I'm on a screen. Now, coming up with the equation, remember how we did that before? So we can say y equals something x plus or minus something. For that constant value at the end, we look where x is equal to 0. So I get a value of -1. So that's the constant value that'll be on its own, -1. And the number in front of x is what this goes up by each time. So what is this going up by? -10 to 7, to -4, to -1, to 2. You might have guessed it. It's going up by 3 every single time. And that's the value that goes in front of x. And it's positive. So I have an equation of y equals 3x minus 1. From the table of values, I was able to plot or come up with all the coordinate points and plot them on my graph, and then draw a line through them all. So let's look at some tips. So if you're given an equation, you should be able to plug values in, come up with values for x, -3 all the way to 3, if you can, or -3 to, in this case to 2. As long as you have, and then include that point 0, and then make your coordinate points and convert that to your graph, right? So if you're given an equation, you can come up with a table of values so you can graph it using your coordinate points. For tip 2, if you're given a table of values, then you can just take that table of values. You can first of all plot the points because they're easy, but to come up with the equation, you want to find that pattern, what they go up by every time. That's the coefficient in front of x. And you want to find out where x equals 0, and what your y value equals, and that will be your constant value at the end. If you're given just a graph, though, and you have all these points, you can create a table of values by going backwards, by saying, okay, well, that point there at the bottom was, -3, -10, and then I can put that in my table of values. And then the next point over here was, -2, -7 down here. And then I can put that into my table of values, and then I can come up with my equation that way. So if you're given a graph, you should be able to come up with the equation as well, working backwards, going to the coordinate points, putting those coordinate points on the table of values, and then seeing what the pattern is and what the value at 0 equals. So hopefully that helps for this lesson. If you get stuck, go back and let me know if you have any questions as well.